After a successful login, Spring Security has to remember who you are. But where exactly does it store that information? And in an application handling hundreds of concurrent requests, how does it make sure one user's authentication never leaks into another user's? In this video, we'll break down how Spring Security actually handles this using the authentication object, the security context, and the security context holder. And by the end, you will not only be able to access the authenticated user from anywhere in the application, but you will also understand the hidden mechanism that keeps every user's data completely isolated, even under heavy load. Let's get in. Let's start from the inside and work our way out. After a user logs in successfully, Spring Security creates an authentication object. This object is the complete identity card of the logged in user. It holds 4 things. First, the principal. This is the identity of the logged in user. For username password login, this is typically a user details object. Second, the credential. This is the password. After successful authentication, Spring Security deliberately erases this value. The password is no longer needed once the user is verified, and keeping it in the memory is a security risk. So, Spring clears it. Third, the authorities. Authorities are users' roles and permission. It determines whether the user is allowed to access the specific resource. And four, authenticated. This is a simple Boolean flag. After successful authentication, this value is set to true. Now, this authentication object does not float around on its own. It needs to be stored somewhere safe, accessible throughout the entire request. That is where the security context comes in. The security context is a simple container. Think of it as an envelope. The authentication object is the letter inside, and the envelope is what gets stored, passed around, and retrieved throughout the life of the request. Now, let me quickly show you this in the actual source code. Here, I've opened this project in my IDE. This is a new Spring Boot project with only one controller. Let's open pom.xml file. I am using Spring Boot 3. Only 2 dependencies are added. Here they are: Spring Web and Spring Security. Let me show you the controller. This is a REST controller and I have only one get mapping. It simply returns the message hello. Now let us look at the security context itself. Let's search for security context. Here is the security context interface. Let's open it. If this documentation is not visible to you, then simply open your Maven panel and click here and select these options to download sources and documentation. It has only 2 methods: get authentication to retrieve the authentication object, and set authentication to store the authentication object. There's the entire contract, nothing else. Now, since this is an interface, Spring Security needs a concrete class to actually create object from it. If you click this icon here, it shows the available implementation of the class. Here, I am interested with this SecurityContextImpl, this class. Let's open this. This is the implementation of SecurityContext. It has one single field, authentication. SecurityContext is simply a wrapper around the authentication object, the envelope around the letter. So, we have the authentication object sitting inside the security context. But now the question is, who holds the security context? And how does it stay accessible throughout the entire request? That is the job of the security context holder. Think of the security context holder as a locker. Inside the locker, the envelope, our security context, is kept securely. And this is the central utility class that your entire application uses to interact with the security context. It exposes method to get the context, set the context, and clear the context. All the operations you need along with some other utility methods. Let me show you those quickly. let's search for security context holder. Here it is. Let's open it. Let's check what is inside this class. Here, I am interested with this field, security context holder strategy. Let's check what is the value set for this field. Here in this initialize strategy method, in this if statement, it's checking if any strategy name is set. Here we have not set any strategy name, so it will be set to mode ThreadLocal. And here in this if statement, for this mode ThreadLocal strategy name, it is setting the strategy as ThreadLocal Security Context Holder Strategy. This strategy is actually uses Java's ThreadLocal internally to give each thread its own private security context. We'll come back into this in a moment. Now let's check other available methods of this security context holder. Let's open this structure window. Here you can see the fields and methods defined in this class. Here we have this getContext. This method retrieves the current security context from storage. This class also has setContext to store the security context. This clearContext method removes the security context completely, and createEmptyContext create a fresh empty security context implementation object. These are the core method our entire application uses to interact with the security context. Now, here is something worth thinking about. Your application is not serving just one user at a time. Think about a real production application. Hundreds of users sending requests at the same moment. If the security context holder managed a single global security context for the entire application, then user A and user B log in at the same time, one would override the other. That means user A could suddenly be seeing user B's username, user B's role, user B's account details. That is a serious security vulnerability. To solve this, the security context holder needs to give each user their own completely private copy of the security context, isolated, invisible to everyone else. And the way Spring Security achieves this is through ThreadLocal. When a request arrives, the server assigns a thread to handle it. Think of a thread as a dedicated worker. Worker T1 picks up user A's request and handles it from start to finish. Similarly, worker T2 picks up user B's request and handles it from start to finish. They are running in parallel at the same time. Now, Java gives each thread a private storage area that belongs to exclusively to that thread. That is called ThreadLocal. Nothing stored in T1's local thread is visible to T2, and nothing in T2's local thread is visible to T1. So, when thread T1 handles user A's request, the security context holder stores user A's security context inside T1's private ThreadLocal storage. Similarly, when thread 2 handles user B's request, user B's security context goes into T2's private ThreadLocal storage. Same security context holder, but each thread gets its own private security context through ThreadLocal. So when you call SecurityContextHolder.getContext from anywhere in your code, it always reads from the current thread's own private storage and always returns the correct security context for whoever made this specific request. That is the isolation guarantee. Now let me show you how this looks like in practice inside a real controller. Let's open our controller. We already have this endpoint returning this simple message. Now let me show you how to access authenticated users' information. Basically, there are two ways. The first way and the simplest is to inject the authentication object directly as a method parameter. Now in the return statement, I will print the username, and Spring Security automatically resolves this parameter. When the request arrives and the security context is already loaded into ThreadLocal, Spring sees this authentication parameter and injects the current user's authentication object directly into our method. And this authentication.getName returns the username from the principal. Now, I'll run this project. Before running the application, let me configure a username and password. Open application.yml. For setting the credentials of the user, the property is Spring security user name, provide the username, then password, and also assign a role to this user. Now start the project, fill the login form, sign in. Here we are logged in and you can see the response hello followed by the username. Okay, that's working. Now let me show you the second way, which is more explicit and works from anywhere in your application. Let's remove the authentication parameter. Here we are going to use SecurityContextHolder directly, then use getContext to retrieve the security context from the current state's ThreadLocal, then getAuthentication. This gets the authentication object from inside that security context. Now store the result into the authentication object. Start again, back to the browser, provide the credentials and sign in. Same result, hello followed by the username. Now, you might also want to access the user's role. Let me show you that quickly. Call getAuthorities method of authentication. This getAuthorities returns the collection of granted authorities assigned to this user. Stream over them. Use map to extract each authority name. Provide lambda expression, getAuthority, and join them into a single string. And store them in a role variable. Now in the return statement, let's print this role. Now again, restart the application and back to the browser, provide the credentials, sign in. Here we can see the username and the roles printed in the response. This is the direct practical payoff of everything we discussed in the diagram. The authentication object was created at login, stored the security context held inside the security context holder via ThreadLocal, and now we are reading it right here in our controller. No database call, no re-authentication, just this security context holder .getContext.getAuthentication. Now let's understand how this all connects across requests. How does the security context get saved to the session after login? And how is it restored on the next request so that our controller call just worked without logging in again? Let me show you the exact source code. Let's open the AbstractAuthenticationProcessingFilter. This filter is responsible for checking the authentication. I have discussed it in my previous video. You can check if you want. The link of that video is in the description. Here, navigate to the doFilter method. Here, check this statement. It attempts to authenticate the user and the result is stored in an authentication object. Let me place a breakpoint here. Back to the browser, refresh, nothing happened. Let's log out. So update the URL and log out. Now again, in the login form, provide the credentials and sign in. It stopped at the breakpoint. It's trying to authenticate. In my previous video, I explained what happens inside this attempt authentication method. If you want to check, again, you can check that in my channel. So here, I'll just step over. Our user is authenticated. So a fully populated authentication object is returned. Here in this debug panel, here is the authentication object. This is the fully populated authentication object. See, we have this principal. This is the user details of the authenticated user. Here is the credentials. This is basically the password. And this value is cleared for security reason. Then we have these authorities and authenticated is set to true. Okay, let's continue our debugging. Step over again. It is now calling the session strategy. This handles session fixation protection. Step over again. Now it is calling successful authentication, passing the authentication object as a parameter. Let's step inside this method. Here, first it creates a fresh empty security context using createEmptyContext method of SecurityContextHolder. Then it sets the fully populated authentication object into the security context. Then it loads the security context into the current thread's thread local via setContext method of SecurityContextHolder. Because of this, our controller can just call the get context to get the security context and get authentication to get the right user. Step over. This saves the security context to the HTTP session so it survives beyond the request. Let's step inside this save context method. We are now inside delegating security context repository. In its save context method, we have this for loop. This loops through all the available security context repository implementations and calls save context on each one. Let me briefly explain what security context repository is. Let's open this security context repository class. It is a Spring security interface that knows how to persist security context data, load it later, and check whether a security context already exists for a given request. Let's check inside this interface. Here you can see a few methods defined. Save context to persist the security context. Load context to obtain the security context from the supplied request. As of now, this method is replicated. Here you can see this comment from Spring Security 6. This load deferred context is used to load the context. And here this is the load deferred context. This method loads the context lazily for the current request. And we have this content context. This one is used to check whether the security context already exists in the current request. As this is an interface, we cannot create object out of it. We need to concrete implementation of this interface. Click on this icon to check the available implementation class. At this time, we have these 5 implementation available. Now, let's go back to the previous for loop. Here it is looping through 2 of the implementation of security context repository. This one, HTTP session security context repository and request attribute security context repository. Let's step into this save context call. We are now inside HTTP session security context repository. Let's step into the save context in HTTP session. Step over. Here, it's creating an empty security context using generate new context method. Let's check this method. Step into this method. This method calls create empty context method of SecurityContextHolder. This method returns a new security context instance. Back to the previous method call. Then let's step over. Here in this if statement, it is checking whether the current context is still the default empty security context. At this point, our user is authenticated. So this security context is changed. It will not enter into this block. Step over and it enters into the else block. It's checking if session creation is allowed. Step over. Step into the set context in session method. Here it saves our security context into HTTP session using the key Spring Security Context. Let's resume the application. Now I am authenticated and it shows my information. After successful authentication, the server returns a JSession ID cookie to the browser. The browser holds the session ID and the server holds the actual security context. That session ID is the bridge between the two. Now let's see what happens on every subsequent request. This is why our controller works without re-authentication. Let me show you what happens when the browser sends a request with the JSession ID. Back to the browser. Let me show you where the JSession ID is stored. Open the developer console. Navigate to the application tab. Inside storage, we have cookie. In cookie, for this local host, we have this cookie saved, JSession ID. And this is the value. This is the actual session ID. With this session ID, our application will identify the session stored in the server. Now, how this session ID is sent? Let me show you. Navigate to the network tab. Here, we need to reload the page. Here is the request to localhost. Let's inspect this request. Make sure this header tab is selected. There are a couple of information here, but I am interested with the request header. Here, as a cookie, this JSession ID is sent to the server. So for every subsequent request, this JSession ID, that is basically the session ID, that is sent to the server. Now let's check how the session is retrieved from the server end. Let me open the filter list in the console. Here, among couple of other filters, I am interested with this SecurityContextHolderFilter. This is at position 3 in the filter chain. This is the filter responsible for restoring the security context on every subsequent request in Spring Security 6. Let's open this filter and navigate to doFilter method. Here, check this statement. It's a supplier, a lazy wrapper. Actual session lookup will only happen the first time something calls getContext during the request. It's calling load deferred context method of SecurityContextRepository. Let me add a breakpoint here at this line number 79. And I am also interested with another class. Let's search for that. Make sure this all is selected and include non-project item is checked. The name of the class I am interested in is Manager Base. Make sure it's from Apache Catalina session. Let's open this class. This class is not part of our Spring application. This is the part of the server library. Now I am going to navigate the method named findSession. Here we have these two overloaded method. I am interested with this one that accepts single string. This method accepts ID as method parameter. This method actually receives the JSession ID. Let's add a breakpoint here. Now back to the browser and refresh. Great. Our application paused at the breakpoint. We are inside the findSession method of manager base class and check the value of the ID. This is the same JSession ID the browser sent as header. And in the return statement, it's simply trying to get the session from the session storage. Okay, we no longer need to inspect this class further. So let me remove the breakpoint and resume the application. Now it paused at another breakpoint in the SecurityContextHolderFilter. Here it is calling load deferred context method of SecurityContext library. Let's check which context repository is selected here. In the debug panel, here is the variable. Let's expand this. See, as before, we have this HTTP session security context repository. It's calling load deferred context method of this class. Let's check that. Open the class. And I am interested with load deferred context method. In this method, we have this supplier. In this lambda expression, it's calling read the security context from the session, and it is passing the session as an argument to that method. Let's see what is in this session. IntelliJ IDEA has a fantastic option to evaluate an expression. We can select the statement, then right click here, choose evaluate expression. Here in this input field, we have this expression that we are interested with. Click evaluate. See, it's now showing the session. Let's expand the session. Here is the ID that is associated with this session. And this is the same JSession ID that is sent from the browser. Here we have this attribute. Expand this. Here we have this key, Spring Security Context. This is the key to identify the security context stored in the session. We just saw it previously. And if we expand this, here we have this object representing security context. Expand further. Now we have this authentication object inside. And inside authentication, we have principal, credentials, that is null as expected, authorities, and authenticated, and it is set to true. This is the architecture of Spring Security Context we saw before. Security Context Holder Authentication. Authentication holds the principal, credentials, and other informations. And Spring Framework gets this from session and allow users to access the protected resource without requiring them to re-authenticate. Now, let's step over. This places that supplier into the current state ThreadLocal storage. From this moment, any call to SecurityContextHolder.getContext anywhere in this request will trigger the supplier, which will go to the session, fetch the security context, and return it. Let me step over. Here, this passes the request down to the rest of the filter chain and eventually reaches our controller. Step over this. At this time, the controller has run. The response has been prepared. Now it's in the finally block. This is the cleanup line. It's critical that it is inside the finally block. It runs no matter what if an exception was thrown somewhere in the controller or service. Let me hover over Security Context Holder strategy to confirm what this called ThreadLocal Security Context Holder strategy. This is the default strategy that uses ThreadLocal. So clear context here clears the current thread's ThreadLocal storage. This is what keeps the thread pool safe. As Spring Boot reuses threads, the same thread that just handled our request will handle the next user's request. If we did not clear here, the next user's request would inherit our security context. That would be a serious security problem. The finally block guarantees that never happens. And there, our controller returned the username and roles correctly. No re-authentication, no database call. Our security context has restored from the session, placed into ThreadLocal, read by our controller, and cleaned up all automatically by the single filter. Okay, let's review all of these one final time. At login, AbstractAuthenticationProcessingFilter creates a security context object, sets the fully authenticated authentication object into it, loads it into ThreadLocal via Security Context Holder, and HTTP session Security Context Repository saves it to the HTTP session under the key Spring Security Context. The browser receives a JSON ID cookie. On every subsequent request, the browser sends the JSON ID. Security Context Holder filter runs early in the filter chain, wraps the session lookup in a lazy supplier, and places it in ThreadLocal. The first time our controller calls SecurityContextHolder.getContext method, the supplier fires, loads the security context from the session, and returns the authentication object. At this time, the username, roles, everything is available. After the response, the clear context method in the finally block removes the security context from ThreadLocal. Now, the thread is safe and ready for the next user. Now, you understand the complete picture about how Spring Security assigns each user their own authentication context, isolate it using ThreadLocal, persist it in the HTTP session, and restore it on every subsequent request. This is the internal machinery that runs silently behind every secured endpoint you have ever built. But knowing how Spring tracks a user only the half of the story. The next important thing is to implement the real authentication system. You can check my next video to know how a user actually gets authenticated against a real database. Not an in-memory user store, not hard-coded credentials. A proper production-grade authentication flow backed by a real database. In that video, I have built a project and shown every step how to authenticate the user against a real database. Hopefully, you will find that video helpful. See you next. Till then, bye-bye.